In this video, we'll talk about different types of solvents in organic chemistry and their effect on nucleophilic substitution reactions. We will follow the rules of like dissolves like, polar dissolves polar, and nonpolar dissolves nonpolar. There are three types of solvents in organic chemistry: nonpolar solvents, polar protic solvents, and polar aprotic solvents. The first type of solvent we'll talk about are nonpolar solvents. And I have two common nonpolar solvents pictured here, heptane and cyclohexane. What we find in organic chemistry is nonpolar solvents are not very good for most substitution reactions. Because we start with polar starting materials, we have polar intermediates and polar products, we find that those materials are not very soluble in nonpolar solvents. What's interesting about heptane and cyclohexane is their symmetry, and we can draw a line of symmetry through the middle of each molecule. And so when you see symmetry in molecules, it's a good indication that you have a nonpolar solvent. The next type of solvents we'll talk about are polar protic solvents. And I have some common polar protic solvents listed here. Here we have methanol, and we have an ethanol, water, amine, and a carboxylic acid. And what we'll find with all these solvents is hydrogen bonding. And you'll find a hydrogen bonded to either an oxygen or a nitrogen in these molecules. And what that means is there's a partially positive charge on that hydrogen, so it makes it easily ionizable. And that hydrogen is attracted to the negative charge of our nucleophile. So what's going to happen is it's going to hinder or it's going to slow the reaction. And we can say then that our nucleophile is solvated and it's turned into a weak nucleophile. And because of this, polar protic solvents favor SN1 reactions. The last solvent we'll talk about are polar aprotic solvents. And again, I have some common polar aprotic solvents listed here. And using acetone as an example, we see that the solvent is still polar, with a partial positive charge on the carbon of the carbonyl and a partial negative charge on the oxygen. What we'll also find is we have hydrogen bonded to carbon at these methyl groups, so we don't have hydrogen bonding because those hydrogens are bonded to carbon, not oxygen or nitrogen. Those protons are not easily donated in solution because of the steric hindrance of those two methyl groups on acetone. So when we have a polar aprotic solvent, our nucleophile is not affected in the solution. It stays a strong nucleophile. So this means that polar aprotic solvents are very good for polar reactions, specifically nucleophilic substitution reactions. So when we see polar aprotic solvent, we want to think an SN2 reaction. So to review solvents in organic chemistry, we can think of nonpolar solvents as no good for our reactions. Polar protic solvents are good for SN1 nucleophilic substitution reactions, and polar aprotic solvents are good for SN2 nucleophilic substitution reactions.